that's what we just got done doing. So now we are going to try to extend this. In the next couple days, for the rest of the week, we're talking specifically about polynomials and exponentials when we look at our derivatives. So first off, let's consider when your derivative, or when your function is a constant. So f of x equals 5, f of x equals negative 3. Those are just horizontal lines. We know the derivative is the slope of the tangent line. Okay, in this case, the tangent line is going to be the line. What is the slope of a horizontal line? 0. So the derivative is 0. So what this tells us is that anytime you have the derivative of a constant, it's an automatic 0. We've seen that show up in a couple of our higher derivatives. I'd like to prove it just because I know you guys don't usually believe me when I tell you things. So if your function is just a constant, then if we did the limit as h approaches 0 of f of x plus h minus f of x all over h. F of x plus h, if you plug an x plus h in for your variable, there is no variable, so it's just c, minus f of x is just c over h. C minus c is 0, so you get the limit as h approaches 0 of 0, which is 0. So that's our proof. You're not going to have to prove these, but I think every now and then it's good for me to show you what a proof would look like. So that is now a fact. Anytime you have a derivative of a constant, you can tell me it is 0 without showing any work. You don't have to work it out any longer. So let's try to extend this and see if we can figure out a few more of these derivatives. So we're going to look at just plain power functions to start with. So if you just have y equals x, what's the slope of that line? Y equals x, that's just a line with a slope of 1. And so since it's a line, the tangent line would be the same. So if our function is just x, then our derivative should be 1, because the slope of that line is 1. Now, when we get into a higher power, like x squared and x cubed, it's no longer just a line. So the tangent line is not always the same. So your derivative is not going to be just a number, it's going to be a formula. So let's take a look at the case when n equals 2. So that's like saying f of x is x squared. If we work that out, the limit as h approaches 0 of f of x plus h, so that would be x plus h squared, minus f of x, so that would be x squared, over h. So if you FOIL, you get x squared plus 2xh plus h squared minus the x squared. What happens here?
X squared cancels.
Cancellation of a 2x plus h. So then if you plug in a 0 for your h, you get 2x. So the derivative of x squared is 2x. Let's look at the case when our power is 3. So that's like saying your function is x cubed. So you have 1 as h approaches 0 of x plus h cubed minus x cubed over h. If you write that 3 times in FOIL, can I just tell you what you get? Okay, so that's x cubed plus 3x squared h plus 3xh squared cubed. And then we still have that minus x to the third. So then what happens?
X cubed.
And cancel that x cubed. So then everything that's left has an h, so we can reduce that. So we get 3x squared plus 3xh plus h squared. If you plug in 0 for all of your h's, what do you get? Okay. So, the derivative of x squared is 2x. The derivative of x cubed is 3x squared. Does anyone want to make a guess at what the derivative of x to the fourth would be?
4x cubed or something.
Uh-huh. All this time. So let's check it. So we think this is going to be 4x cubed. Let's see. So if you did the limit as h approaches 0, f of x plus h minus f of x all over h. So if you wrote that out 4 times and multiplied, you get x to the fourth plus 4x cubed h plus 6x squared h squared. I'm going to run out of space. Plus 4xh cubed plus h to the fourth. And we still have that minus x to the fourth. So my x's cancel. You can drop an h out of everything remaining. And you get 4x cubed plus 6x squared h plus 4xh squared. So then if you plug in zeros for all of your h's, you got what you guys predicted, 4x cubed. So how does it work? What's the pattern? How'd you know it was going to be 4x cubed?
From the last one.
The 4 was your power. So the power comes down, and then what do you do for your new exponent?
Oh, you
Subtract 1. Okay, I told you that with x, we got 1. You could do this derivative the same way. This is x to the first, so if you bring your 1 down, then you would have x. If you subtract 1 from the power, that's x to the 0. Anything to the 0 power becomes 1. So that's where that works. So, here is our power rule. This is huge. Tells us if we have a polynomial, if we have x to a power, we no longer have to work that whole thing out. The derivative makes the exponent come down, turns into a coefficient, and then you subtract 1 from the power. Have you ever wondered how on all your problems when you said, did I get this right? I could just look at it and tell you if it was right. This is what I was doing the whole time. Don't you feel rewarded now? You're not angry with me at all, are you?
Why did we learn the hard way?
Because this doesn't always work. When you get into nastier functions, there isn't always a shortcut for doing it, and so it goes back to that rule. So that's why we started with that one. Alright, so here we go. We can find all of these now. So if it's x to the 6th, what would your derivative be? If it's x to the 1,000th, wouldn't you like to work that one out by hand?
Mm-hmm.
What does that become?
1,900.
Alright, if y equals t to the 4th, dy dt, this is just another way of saying derivative, would be?
4t to the
Alright, last one, d over dr of r cubed. That's just another way of saying, give me the derivative of r cubed. So that would be?
3r squared.
I told you it would be a good day.
Are we done with homework now?
Let's give it a little bit longer. What? Are you complaining?
Ag class all over again.
Okay, so if I said 1 over x squared, how would I have to rewrite this so I could use my rule? So it's x to the negative 2 power. So for our rule right now, the only rule we have, it has to be x to a power. So then our derivative, f prime, exponent comes down, so it's a negative 2x, and then subtract 1 from the power.
Negative 3.
Negative 3. You could rewrite it as like negative 2 over x cubed if you wanted, but we can leave it just like this. So on B, I don't have a rule for radicals, but how could I write this? X to the 2/3 power. Isn't this much better than doing it by hand and having to do conjugates and all that mess with it? So our derivative, exponent comes down, so it's 2/3 x, and you subtract 1 from the power. So 2/3 minus 1,
Negative 1/3.
so it's 2/3 x to the negative 1/3.
Me too.
Dude, that's my weakness.
Alright. So far, so good? So, let's talk about, we've done equations of tangent lines before. I want to talk about the normal line as well. A normal line is a line that is perpendicular to the tangent line. Okay, so we know the tangent line, slope of a tangent line is just the derivative. The normal line would be perpendicular to that. When lines are perpendicular, what do you know about their slopes? Like if I said one of them had a slope of 2/3, then the line perpendicular would have a slope of? Parallel is the same. Perpendicular, come on. Opposite reciprocal, so being negative 3/2. You flip it and change the sign. Okay. So you had points in the past, or problems in the past, where we had to write equations of tangent lines. And we had to do the derivative to get the slope of the tangent line. We had one on our quiz yesterday. So this time I want the equation of the tangent and the normal line to the function f of x equals x times the square root of x at the point 1, 1. Now again, to do a derivative, we only know how to do it if it's x to a power. So I need to rewrite this. The square root of x is like x to the 1/2. If you're multiplying, what do you do with those exponents? Add them. So this is like an x to the first times an x to the 1/2, so 1 plus 1/2 is 3/2. So your derivative would be what? 3/2 minus 1. Yeah. 1 is like 2 over 2, so 3 over 2 minus 2 over 2 is 1 over 2. Okay, that's our equation for the slope of the tangent line. We're talking about at the point 1, 1. So let's do the tangent line first. So your slope would be 3/2 times this x to the 1/2, that just means the square root of x. So 3/2 times the square root of 1 is just 3/2. So now we have a point, and we have a slope. So now we can plug into y equals mx plus b. So y is 1, and this 3/2, or x is 1, plus b. So 1, that's the same as 2 over 2, minus 3 over 2. So my equation is y equals 3 halves x minus 1 half. Now the normal line is perpendicular to the tangent line. So what will the slope be? You always flip it and change the sign, so negative 2/3. We have the same point, 1, 1, so plug into y equals mx plus b. So if I add my 2/3 over, 1 is like 3 over 3 plus 2 over 3 is 5 over 3. So our equation is y equals negative 2/3 x plus 5/3. So far so good? Why don't you guys try this one? So your derivative, exponent comes down, subtract 1 from the power, so you get 4x to the 3rd. We want the equation of the normal line. So first, we have to think about the tangent line. Okay, the tangent line, to get its slope, you would just plug what in for your x? -2. So you're just plugging your -2 into your slope formula. So you get 4 times -8, which is -32. So that means the normal line will have what slope?
1/32.
Change the sign and flip it. So now I have a point and I have a slope. Plug into y equals mx plus b. So 16 equals 1/32 times -2 plus b. This would be -2/32 or -1/16. Add that over. So we would get 257/16. Or 16 and 1/16. So our final equation is y equals 1/32x plus 257/16. I'd like to do just a little more with the derivatives. Just extend it a little bit and then we'll stop for today. So the only thing we've learned how to do the derivative of so far is x to a power. We can extend this a little bit. We have a constant multiple rule that says if you have a constant times your function, you can pull that constant out in front. So in other words, what that says, I think instead of doing a proof, if that's okay, I'm going to do an example here. So if I said my function was -5x to the 10th. When you do your derivative, it's telling you you can just keep that -5 out in front and then do the derivative of x to the 10th. What would the derivative of x to the 10th be?
10x to the 9.
So then you get a -50x to the 9th. So this is telling us if we have that coefficient in front, we can still do our derivative like normal. You'll just end up multiplying by your coefficient. Do you guys want to see the proof for it, or do you trust me? Alright, let's do a couple then. So if I ask you to do the derivative of 3x to the 4th, the 3 just stays times, what's the derivative of x to the 4th? 4x cubed, and so we get 12x to the 3rd. So all you really end up doing is when you bring your exponent down, you multiply it with the number that's there. So if I ask for the derivative of negative x, okay, this is like x to the 1st, so the derivative of x to the 1st would be 1x to the 0. What's anything to the 0 power? 1. So we get negative 1 for our final answer. It also works out that if you have multiple terms, you can do the derivative of each term separate. So the sum rule says if you have the derivative of two functions added together, you do individual derivatives, or you could write it as f prime plus g prime. Do you guys want the proof, or you want to just accept? Just accept it, everybody's okay with that? The same is true with subtracting. If you have things subtracted, you can just subtract your two derivatives. So now, instead of just being able to do derivatives of x to a power, you can do any polynomial. So if I asked you to do the derivative of this huge thing, that would have taken us forever before today. But now, this is telling me I can do the derivative of each term as I go along. So what's the derivative of x to the 8th? Plus, okay, 12x to the 5th. So
12 times 4x to the 5th.
12 times
Oh,
5x to the 4th. So you could turn that into a 60x to the 4th. Okay, minus 4x to the 4th. So it would be 4 times, what's the derivative of x to the 4th? 4x to the 3rd. Plus 10x to the 3rd. So 10 times the derivative of x to the 3rd. What's 30x squared? So we'll get a 30x squared. Minus 6 times x. What's the derivative of x? 1, so that's a minus 6. Plus, what's the derivative of 5? Now. 0. 5 is a constant. So when you do the derivative of it, it turns into 0. Another way to think of this, 5 is like 5x to the 0 power. So when the 0 comes down, the whole thing turns into a 0. So this is our final derivative. Just a couple quick questions to stop for the day. If I asked you to find the derivative of 3x minus 4 squared, what would you have to do before you could do that derivative? Square it. You have to realize that means there are two of them, so you have to multiply it out to the first before you can begin. So you would get a 9x squared minus 24x plus 16. And then when you do that derivative, exponent comes down, so 9 times 2 gives me 18x, subtract 1 from the power, so it's just the first, minus, what's the derivative of 24x? 24 times 1, so just 24, and what's the derivative of 16? 0. So on your homework there's going to be one or two like that where you have to first multiply it out, because we can only do the derivative if we have things, individual terms. If I said your function was like do we have a rule for how to do the derivative when things are divided? No. So we have to simplify all of this first. A square root of x is like x to the what power? 1/2. So we could, when you divide, you subtract exponents. So 3 minus 1/2, so it's like 6/2 minus 1/2 is 5/2. Minus 3 x to the first over x to the 1/2. So 1 minus 1/2, 1/2. Plus 4 over x to the 1/2, so if you want to bring that up, it would be a negative power. Does everybody understand what I did right there?
Yeah.
So you have to do the algebra first. We are very limited on what we can do the derivative of. You have to have terms added together. So then if I ask you to do this derivative, you'd have your 5, then x to the 5 halves would be 5 halves x. If you subtract 1 from the power, 5/2 minus 1, so 5/2 minus 2/2. Minus 3, so this one, the 1/2 comes down. 1/2 minus 1 is negative 1/2. This one, the negative 1/2 comes down. Negative 1/2 minus 1, so negative 1/2 minus 2/2 is negative 3/2. So sometimes you have to simplify before you are able to find your derivative. Any questions for me? So that's our stopping point for today. I want to give you guys time to work on homework. This first chunk is today's assignment.